Okay, let's continue our final part of the journey in bond valuation. Uh, Previously, we studied how we can apply the amortization technique to do the uh, bond valuation. A key assumption there is constant yield, right? So we assume yield is a constant. We actually use the one from the beginning. So we use the yield at the purchase time, t equals 0, and assume I is a constant throughout the entire maturity, right? From 0 to n for a specific bond. I does not change. Uh, well, of course, that is a very strong assumption. So here we apply a different method known as straight line method to determine the bond valuation. So we will see in a minute that here we actually don't apply or don't assume everything is a constant, but um, the assumption is coming from a different angle. Okay, let me walk you through the essential ideas under the straight line method. So here we have two essential ideas, two steps. In step 1, we calculate the book value at 0 and at time n. So at 0 it's just the price, right? So BV0 is nothing but the bond price, and BVN is nothing but the redemption value C. So those we know. And then we simply draw a straight line to connect those 2 points. So what I mean is, let's draw a graph. So here's 0, here's the maturity time n. So I know my price is here. So here's P. So I know my book value. The y-axis is book value. This is time t, time. So assume this is C. Okay, so what I do is I use a straight line. Oh, not exactly straight. Let me do it again. Okay, I use a straight line to connect those 2 points in this 2-dimensional space, right? And whenever I need, so let's say I want to know my BV at this small time t, I just draw a line. Then this will be my BV at time t. Right? It's very simple, right? So that's why, although we probably argue that the previous assumption of a constant yield is very strong, we are trying to do something different. Indeed, we are doing something different, right? But what we are doing is also very simple, right? In the sense naive. This is the by the way, this is for discount bond. Because when we have a discount bond, the BV actually is increasing. So if you study the previous case, we know that. So meaning we do have another case for the premium bonds. I quickly draw the graph. So everything's the same except now P is bigger than C. So again, this is the terminal time, right? So I draw a straight line to connect, right? So for time t, here's time 0. So what I do is I draw a vertical line. The intersection would be the book value. So it's simple, right? That's why this method is called the straight line method. So we know the book values at 2 terminal times, right? At the beginning time and at the ending time, at 0 and small n. Since we already know 2 points in a 2-dimensional space, we can always draw a straight line to connect them. And we assume all the other book values are exactly on this line. So it helps us to determine the book value, right? So that's why I have a very important note. Please do not apply the prospective method or the retrospective method we used before to calculate the book value. It does not apply here. Okay, as I already mentioned, in the straight line method, all the book values will be on the line. So use the straight line to determine your book value. Okay, that's my comment. So once we know book value, then of course we can compute everything, right? Remember, under this method, we actually have a very special result about the premium amortization. Again, what is premium amortization? Premium amortization. Let me first write down the formula for BV0. This is the price, so I can use this is my coupon times the present value of all the coupons plus the present value of my of the redemption value C, right? And obviously BVN is nothing but the redemption value. Okay, those are easy to compute. By the way, what is PAT? PAT equals BVT minus 1 minus BVT, right? And since we have a straight line, so the distance is always the same, right? The same x will give you the same y. So in that regard, this will be BV0 minus BVN divided by n, because all the PAs are the same, meaning PAT is the same for all t between, of course, between 1 and n, right? That's because we apply a straight line. So let me use a different color. So let's say here is t minus 1, right? So what is so this part, right? So the vertical difference is the same as long as you have it for one period, right? So always the same. It's a straight line. So it's obvious. You can even see that from the graph. So once we know the premium amortization, I can easily calculate the interest now. Again, I do not apply I times the previous book value. That's because now I don't know my I. My I may change, right? That's the whole point of proposing this new method, because we don't like to assume a constant interest or constant yield. So do not apply IT equals I times BVT minus 1, okay? Because this, I don't know anymore, okay? It's IT instead of I. But I still know this does not change, right? This is still holds, okay? So this is CG is a constant. PAT is a constant, meaning this is a constant, right? And of course, well, you can also we still have BVT equals the previous balance minus PA. Okay, that still holds. So we do have an example. Everything is the same from the previous one. So our price BV0, it is still 92.15. Our BVN, actually BV10 is 100. So what I have my PA is always the starting value minus my ending value divided by n. Here's t. Here's n is 10. So I can calculate this is negative 0.785, right? So that means my accumulation of discount is always 0.785, right? Because this is a discount bond. So we take the negative of PA to do the accumulation of discount. Interest is CG minus PAT. So it's 100 times 2.5% minus becomes plus. So again, this is a constant, as I already mentioned, right? So once you do this, you will see that this is a constant, right? So if we apply this concept So let me highlight this. This is not a constant anymore. So let me put it in a different color. So this is actually IT. Okay, since this is a constant and this is changing, so your IT is varying from time to time, right? So this is different from our previous assumption that I is a constant yield. In this case, I is actually changing. You can actually calculate what I is, right? So if you want. The textbook also give you a table. I would actually suggest you to get the same table using Excel. It's actually easier than the one I did, right? Because here pretty much everything is a constant except the book value, right? And book value can be computed. You actually have two methods to calculate book value. The first method is to directly use this straight line, right? You can calculate the slope, right? The 2-point equation, right? So you can calculate the slope and intercept, and all you need to do is to plug in time to get BVT. That's a mathematical work to get it done because this is a straight line. Alternatively, you can also use this. Once we get PA we can easily compute, right? We know the price, we know the redemption value, so we know PA. Once you know PA, obviously you can apply this formula, right? So meaning BVT equals BVT minus 1 minus PAT, right? So you need to start from BV0, right? So it's recursive formula. So BV1 equals BV0 minus PA. Well, PA is a constant, so I don't need to write T anymore. And then BV2 equals BV1 minus PA, right? So you can actually see here, this is BV0 minus 2PA, right? So you can see how you can get the result as well, right? That's a straight line method. Now we discuss a different type. So far, we have only considered regular bonds. Now let's talk about callable bonds. Our main analysis will be based on an example because our study will be under a simplified scenario. Pricing callable bonds, it's actually not easy at all. It's rather a complicated issue. And here we make a lot of assumptions. The textbook actually has 2 pages. 2 pages, not 105 to 185 to 186. I actually don't want to follow the textbook. I want to use an example to demonstrate what the textbook means. But first, let's go over some terminology. So a callable bond is a bond that can be redeemed earlier by the issuer. So the issuer has the right to decide whether they want to terminate this business earlier or not, right? Of course, in order to redeem it earlier, the issuer needs to pay the bondholder a certain amount of money. That money is called the call price, okay? In most cases, the call price will be bigger than the redemption value. So let's say redemption value is $100. The bond issuer might need to pay, let's say $110 to call it earlier. So in that case, 110 is the call price, and the difference, $10 is the call premium, the cost to the issuer to call it earlier, right? Otherwise, they need to wait. Okay, by waiting, the issuer needs to pay coupons in between, right? If the issuer calls earlier, the business is done, right? It does not need to pay future coupons. Everything ends there. It's the same as paying your mortgage earlier. Once you pay your entire mortgage today, you don't need to pay anything in the future, right? Sometimes there is a call protection period, meaning that the issuer might need to wait for some years in order to have the right to be effective, right? Let's say a company issues a 20 years bond, right? Maybe it cannot call it back within the first 5 years, well, just to give the bondholder more time to accumulate coupons, right? Otherwise, it may not be a fair deal to the buyer, right? So someone issues a 20-year a bond. If it can call it back anytime, maybe it will call back before the first payment, right? If the call price is low enough. So here we need to separate our analysis into two cases. Case one is for a discount bond. Case two is for a premium bond. So obviously you should know the definition, right? A discount bond is a bond when its book values are less than the redemption value. So let's say the redemption value is 100. You will see the book values are always less than 100, of course, except the last one. Last one will be equal. And the increase over time. So BV0 will, BV1 will be bigger than BV2. BV2 will be bigger than BV1, right? Which we already saw in the last video. But for a premium bond, everything is on the opposite side. The book values will be greater than the redemption value, of course, except the very last one when they are equal, and that the values actually decrease over time. The first BV0 is the highest or the biggest value. We already know how to determine, right, whether a bond is a discount bond or premium bond. We just need to compare two rates, G and I. So now let's assume for a moment that, let's say I want to buy a bond, or I am a bond holder. G is what I get, right? G is the coupon, which I can collect. I is the cost, for me to buy this bond. If I don't buy this bond, I can put my money in a saving account and earn interest rate I, right? So if what I receive is more than the market rate, I will need to pay premium, right? What you receive is more than what you would normally get from a bank, then you need to pay premium rate. Then we have a premium bond. So if what I'm getting is less than what any bank can offer, I will only buy this bond if it's priced at a discount, right? Everything makes perfect sense, right? Now let's use an example to demonstrate how to price a callable bond in a naive scenario. So here we have a 10-year callable bond with semi-annual coupons. So we already know N is 20, R is 3%. It doesn't say anything, so we assume it's redeemed at par, and its price is $100. So F equals C equals, so this is also equals to G equals C equals $100. The call price after 5 years is 102. So part one, determine the price of the bond to yield of 7% compound semi-annually. So in the first case, I is 3.5%, right? So since I is greater than G, so this is a discount bond. If this is a discount bond, then all the BVs will be less than the redemption value, right? So of course here T will be less than N. The book value of this particular bond will always be less than 100. It doesn't make sense for the bond issuer to call it at 102, right? So the issuer will not call at 102, not 102, not 110, 102, right? Since the BV at 5 years is less than 100. The bond issuer is not stupid. He will not pay $102 for something that is less than 100, right? So call is useless. So this call right is useless. Meaning, although this is a callable bond, but the issuer will not call it earlier. So meaning That means it will let it expire by the end of 10 years, right? Now, how do we price? Then it's easy, right? Then to price, we need to calculate the coupon. Coupon is 3. I have 20 terms to go, and my interest rate is, well, what's my interest rate? My interest rate is I, so 3.5% plus $100 in the end, negative 20. So we can easily calculate the price is 92 point. So again, this price is less than 100 as expected. Again, this means it's a discount bond. For discount bond, it will not call for more than $100. Maybe it's possible to call it at, let's say, 95. Then you need to discuss, right? The next scenario is I equals 5%, or not 5%. The compound is 5%, so I is 2.5%. In this case, G is greater than I, so this is a premium. So premium. So this is a premium bond. So BV will always be bigger than 100. So it is possible the issuer will call it earlier if it's to his advantage, right? So in our textbook, we always assume that, okay, so if this is the case, we assume the bond issuer will call it earlier. So let's take a look at what's going on, right? So here I have 20. In the end of 5 years, which means it's 10, 6 months. Here's 11, 12. The coupon is $3. $3. Okay, so here is 100. In our textbook, they assume if we have a premium, well, just assume it will be called earlier at the end of 5 years. But let's take a look whether it's a good decision for the issuer. So in this case, if you assume for a moment there's no call and it holds till the maturity, then the BV at 10 means 10 6 months. So it's by the end of 5 years. What do we have? We have 3 times A10, 3.5% plus 100, 1 plus 3.5% to negative 10. If you calculate the price, the book value will be 104.376. This is actually bigger than 102. So it makes sense for the issuer to call. That means the issuer can now pay $102 to close this bond, which is now worth $104 and about 38 cents. Of course, the issuer should call, right? Because it gives it the right to use $102 to buy something that is worth more. So the issuer will call it earlier at the end of 5 years. So now how can we price? Now, if we know it will be called, so here's 5 years, then we need to restart everything. So here, let's put 102. So that is the key. Because the issuer will call it at the price of $102, this bond will not last 10 years. It will end at the end of 5 years. Okay, the issuer will call this bond by the end of 5 years. So this is the total cash flows to the buyer of this bond. Then we can price. So here it will only last for 5 years. So 10 payments, 2.5. No, here's 2.5, not 3.5. 2.5 plus 102 times 1 plus 2.5, negative 10. So then we calculate the price is 106.28. So the buyer will pay this amount at time 0 for this specific callable bond. Okay, the last part we study is how do we price a bond if the time t is somehow between two payments? Remember, so far what we have done is we always consider at exactly the payment times, right? 1, 0, 1, 2, all the way to 20. Those are the payment times, right? Here I will receive a coupon, here I will receive a coupon. So those are the payment times. What if it is in between 1 and 2, right? I already received the first coupon, but I haven't received the second yet. Now I want to sell it, right? So the question now is, how do we calculate the value of a coupon that is not paid yet, but will be paid? We know that, right? So now the question is, how do we account for this partial ownership, right? In my example, I mentioned that, let's assume I bought this bond at time 0, okay? I already received the first payment in 6 months. Now let's assume now is month 10. Okay, I still need to wait for another 2 months or 3 months, depending on whether it's beginning or the end. So let's say right now is the beginning of the 10th month. I will need to wait for another 3 months to receive the next $3. But I don't want to wait. I want to sell it. Okay, now how do I price it? Should I price the entire $3? Probably not fair, right? Because I only owned this for 3 months instead of 6. Right? I cannot put everything with it, but also I don't want to discard it, right? Because this $3 is for the entire 6 months. I already owned it for 3 months. I don't want to give that up, right? So how do we decide? Is it half-half? Right? Seems to be fair because $3 is for 6 months. I already owned it for 3 months. If I transfer this bond to another person, we should split it up by half-half, right? Each one gets $1.5 at time 2. But now I'm selling it at this point, right? I will need to do some kind of discounting of $1.5, right? So that's something we're trying to do. With that in mind, let's introduce two notations. One is what we call the clean price. Clean price excludes the accrued interest. So meaning it's the buyer gives up. The full price is the transaction price. It takes into account the accrued interest. Okay. Since this is relatively short term, right? Between two payments, usually there are 6 months. And in between, of course, it will be even less than 3 months. So this is time when we need the day count convention, which I actually introduced very early on, right, in chapter 1. Two common rules, 30, 360, meaning they are 30 days a month, and they are 360 days a year. So those the first rule usually used for corporate and municipal bonds. And sometimes they also have, the second rule is actual number of days in between and actual number of days in a year. This is normally used for government bonds. So how do we calculate the accrued interest? It will be coupon times a fractional time k. K is the number, so let me draw the graph, then you will understand. So let's say this is t minus 1, this is t. Those are the coupon payments, okay? So here I want to sell, this is what we call the settlement date, right? It's between two coupon payment dates. T minus 1 is the previous coupon payment date. T will be the next coupon payment date. Right now, I want to sell it in between. So, so let's call this number of days. Let's call it M1, okay? And then it will be counting from here, let's say number of days, M2. Then my K would be M2 divided by M1. So that's the meaning, right? It's easy to understand, right? So it's basically how long I hold divided by how long the payments between two dates will last. We have a quick example. So here, let's do a quick example. This is May 10th, 04. The next payment will be 9/1st, 04, meaning the previous one is March 1st, 04. Okay, so if we apply the 360 rule, we need to count how many days in between the two. So we will use date plus 5 minus 3. They are 30 days a month. So it's easy to calculate. They are obviously 69 days, right? The rule I use is 360. Okay. This is M2 in my notation. M1 obviously is 180 because it's half year, right? They are 360 days a year. Of course, for half a year, they are 180 days. So K would be 60 divided by 180. So the accrued interest, let's say the coupon is, you can just randomly make a number, let's say 50. Then the accrued interest would be coupon times the fractional number. But if you want to use actual, TUAL, so actual. So we need to count how many days between March 1st and September 1st. Actually, there are 184 days, 4 days more than the previous rule. And you need to count how many days between March 1st and May 10th. There are 70 days. So there will be some slight difference, right? It's not huge, but nevertheless, it's important to know they are not the same. Okay. That's how we accumulate or how we calculate the accrued interest. Now, let's study the how the full price would evolve. Right, full price is. Let's draw a timeline. Then it helps us understand everything. So let's say here it's P T minus 1. This is the full price, meaning if you buy this bond at this time, T minus 1, you need to pay T minus 1. Of course, you can treat it as the book value. Okay, of course, here it would be PT, this is the BVT. What would be the price down here? Right, so that's something we want to know, right? So let's say, so I think the textbook use T plus 1, but of course they are the same. So to be consistent, let's do that. Here's T plus 1, T plus 1. So let S be T plus K. So which means it's K period of time from the previous one. So how do I calculate this? PS. It's easy, right? We know PT, the previous price at the payment time T. Once we know that price, in order to know something in between or some future value, we can apply the accumulation factor, right? Or I can discount back. But when I do discount, I need to note that the BV is the value after the coupon is paid. So I will need to add back the coupon value down there. So FR is the coupon at T plus 1. I will need to add it back. Then I can discount by 1 minus K. Right? So because here is K, here is 1 minus K. This is the key, okay? Don't forget to add the coupon because our book value is the value immediately after the coupon has been made. So it will be the value after the coupon payment. So it's subtracted. So in order to discount back, you need to include the coupon back. Okay. With that in mind, this example, it's not that bad, right? So here, what we have is matures here, June 1st, 08, semi-annual, and somehow I'm trying to settle at October 1st, 2003. Obviously, this is not a coupon payment date, right? It's always June 1st, and then it will be the well, you can call it January 1st, right? So it's not on January 1st or June 1st, so it's not a payment date, and the closest one is June 1st, 03. Okay, here 04. So it's in between. First, let's calculate this. This is time t. This is time t plus 1. So here, PT would be, well, you need to count how many years left, right? So obviously, there are 5 years from t to the maturity time. The coupon is 100 times 4. So the coupon is $4. Okay, there are 5 years, so there are 10 payments. Yield is 6, so divided by 2 will give me 3, plus the par value, which is 100, 1.03, negative 10, discount back. This, your calculator can directly calculate in one step. So I know my PT, right? So in order to know the value at this time, so let's call it t plus k, all I need to do is to do this. Well, this is well, I need to apply the, well, again, the day count rule to calculate what would be the fractional value. So if we apply 360 rule, the days in between would be, well, 1 minus 1 is just 4 months. So 4 times 30, 120 days. And of course, now it would be 120 divided by 180, right? Then I know my value would be 108.53 times 1.03 goes to 120 divided by 180. So I will get the result is $110.69. Of course, if you apply a different rule, this K will be slightly different. Let's say you apply actual, you will get a slightly different rule. This is one method, right? We can also use a different method. I can calculate the price at the next payment time. So it's still 4, but here it will be not 10, right? It will be 9. And when I discount back, it's negative 9 as well. So let's calculate. I will get $107.78. Well, there are a lot of rounding, so let's keep it. So now, how do I calculate? I need to discount back. So PT plus K would be, remember, let's add the coupon. Okay, coupon is $4. Okay, now is 1 minus K, so it will be 1. So here's discount. So it will be 1 minus K. K is 120 minus 180, right? So you can do the computation. Obviously, they will give you the same result, right? So once you know the full price, those P are so-called full price. We call it the full price because we have already taken into account the interest into the price, right? And the clean price is the price that does not consider interest. So clean price will be whatever the price we have minus the accrued interest. Okay, So in this case, in our example, it would be $110.69 minus, okay, so here we need to calculate. So the 4 is the coupon, right? Times by 120 divided by 180. This is how we calculate accrued interest. So finally, this is the clean price. The reason why we want to calculate the clean price is because this is the quoted price in the United States. When you see a bond price, this is the clean price. That's why it's important to know how we can compute the full price, how we can compute the accrued interest, because that's how we quote clean price. Okay, that's the end of this lecture and also the end of this course. Okay,